So we have a lot of the groundwork done. We've established what a force actually is, what are its characteristics, and we've also established that we're going to be dealing with 2D coplanar force systems. So now it's time to turn our attention to analysing systems of forces. Now all a system of forces is two or more forces acting simultaneously. And in our analysis of these force systems, what we're trying to do is determine what is the combined effect or the combined result of all of these forces acting at the same time. So this is actually going to be a pretty straightforward task once we keep in mind the rules of vector addition. Okay, so with that said, we can consider any vector as a combination of two or more vector components. Now when we're analysing 2D force systems, the most common way to proceed is by working out what are the orthogonal vector components of each vector within our system. So if we can imagine a single vector which is acting at some arbitrary angle, we'll be able to work out orthogonal vector components for that vector. These orthogonal vector components are essentially two vectors that are at right angles to each other, that when applied together have exactly the same force effect as the single original vector we started with. So for the rest of this lecture, we're going to be analysing 2D force systems, which is going to basically involve an awful lot of working out orthogonal vector components. So if that hasn't made the most sense to you at the start now, wait until we get through to the end of this lecture and it should make an awful lot more sense after you've seen a couple of examples. In this example, we have a system of three forces with different magnitudes and directions, and our task is to determine the magnitude and direction of the resultant force. Or in other words, if I had to replace this system of forces with a single force that has the exact same effect, what would that force's magnitude and direction be? Pause the video here and try and solve the problem yourself first. So there are really two steps to a problem like this. The first step is to break each force down into common orthogonal components. By this I mean determine the orthogonal components that are parallel and perpendicular to the horizontal and vertical axes. Do this for each force and then add up all of the component forces. The second stage is to combine the resultant force components into a single force vector and calculate its magnitude and direction. So, if this has cleared up the picture for you, pause the video and try and work out the solution. Taking one force at a time, construct your right angle triangle and determine the lengths of each side. It's really important in any structural analysis problem to define a clear sign convention for yourself at the outset and stick to it. I've decided that all forces upwards and to the right will have a positive sign, while all forces down and to the left will have a negative sign. You can specify any sign convention you like once you stick to it and interpret your results in accordance with it. So this would give me Fx equals minus 35.36 newtons and Fy is also equal to minus 35.36 newtons. Now we can simply repeat the procedure for each of the remaining forces. Notice that the 20 Newton force is already aligned along the x-axis, so no further work is required other than to acknowledge it has a negative sign. Next we need to sum up the horizontal and vertical force components. Notice that when we draw the force vectors we don't specify the sign with a minus or plus sign. This is because the direction of the arrow is what's telling us the sign of the force. We only need to write a plus or a minus sign when we have no arrow to tell us which direction the force is applied. The second part of the problem involves combining these force components into a single force vector. Remember, it was the magnitude and direction of this vector that we were asked for in the question. Now that we know the magnitude of the orthogonal components of our resultant force, we can simply use Pythagoras' theorem to determine the magnitude of their resultant, or. The last task is to use basic geometry to calculate an angle that specifies the direction of the force. We have two options here. We could specify the angle with reference to the horizontal axis, as I've shown here. Alternatively, we could specify an angle with reference to the vertical axis. Either option is perfectly valid if it hasn't been specified in the question. This example is very similar to the last one. This time we want to determine the resultant force components that are parallel and perpendicular to the inclined axis. So go ahead and try and solve this one yourself before watching the solution. First things first, we need to specify our sign convention. Now we take each force in turn and follow the same procedure as before. This time, when constructing our right angle triangles, we make sure that the sides are parallel or perpendicular to the inclined plane. At this point, it's the same procedure as before, just applying basic geometry. But remember, adhere to your sign convention. Sometimes the trickiest thing about these questions is working out the angle you need for your right angle triangle. In this case, we know the force component, Fy70, is at right angles to the inclined axis. This means that the angle inside our triangle must be 90 degrees minus 40 minus 20, which gives us 30 degrees. And now we're back on track. Now simply sum up the force components, being careful to observe your sign convention and apply the correct sign to each force component. And that's it. We've determined the components of force parallel and perpendicular to the inclined axis. The component parallel to the inclined axis is 34.21 newtons running down along the axis, and the component perpendicular to the inclined axis is 80.87 newtons pointing into the inclined plane or axis. So we've covered quite a lot of ground over the last 2 lectures. Before moving on, make sure you're able to answer the following questions. What is a force? What are its defining characteristics? And what do the terms concurrent and coplanar actually mean? Try explaining these to somebody else who isn't familiar with the technical details, because in doing that you'll very quickly become aware of whether or not you actually understand what you're trying to explain. But most importantly, make sure you're comfortable analysing 2D force systems. This is really fundamental to everything that we're going to do moving forward from this point.